All right, everybody, we have one more short lecture before we get into actual programming, but this is something very critical to understand before we start trying to develop logic on our screen. When we look inside of our coding window, you might have already noticed this, but you generally have controls on the left and you have controls on the right, and a big empty space here in the middle. And there is a great reason for that, and it's one absolutely fundamental and necessary to understand before going a single step further. The way ladder logic works, we already know it runs from program file 2, and it calls the other programs and it jumps into them one after another one, and it runs from 0 down. But it's very important to understand that each one of these rungs runs from left to right. And why that's critical is because this giant gap here in the middle, all this white space on our rungs, divides our conditions on the left from our outputs, or you might think of them as actions, on the right. So imagine this program is running right now and it's scanning, and we're going to go step by step how the PLC is going to scan this program. It's going to come down here to 0, the rung 0, and it's going to look at this first condition. And remember, the things on the left are conditions. Think of them as if statements. If this is true, then this big white space represents a then, and what happens on the right is what it's going to do, but it's only going to perform these actions if these conditions on the left are met. If it comes to rung 0, it's going to look at bit T4:42/DN, which is an address for what's important to understand right now. It's just a single bit. And it's going to say, if that bit equals 0, then we want to come over here and do this thing. But if we come down to here and this bit is not equal to 0, the PLC is going to skip right down to rung 1, and it's going to say, okay, then is this bit equal to 1? And if it's not, it's going to say fine, and it's going to come down here, and it's going to say, is this bit equal to 1? If it is, it's going to perform this action, then it's going to move down to rung 3, and it's going to say, does this bit equal 1? And if it does, it's going to do, again, top to bottom, it's going to perform this action, this action, this action, all the way down to this action before it goes to the next line. And here we have two conditions on the left, so it's going to say, is this one true? Yes. Is this one equal to 1? Yes. What about this one? Is this one equal to 1? No. Let's imagine that it's not equal to 1. Well, it goes on down to rung 5, so it will not perform these two actions unless both of these are true. And remember, it's going to run through this whole program in about 6 milliseconds. So if these two are true, it's going to do these things, scan the rest of the program, and come back around. And in that time, in that 6 milliseconds, maybe something has changed in the process or in the memory registers, and for whatever reason now, maybe one of these isn't true anymore. So the next time it scans, it won't do these things, and it'll just skip down to 5. So if you don't take anything else out of this lecture, the one thing you have to understand and you can't forget from here going forward, this is the one thing that makes ladder logic make sense, is what you see on the left are conditions. What you see on the right are actions. And for each branch, you have one action. If we want multiple actions to come out of this rung, we have to put each action on a separate branch. What we cannot have is two actions on the same branch. If we try it, the program's going to give us a hiccup, and it's going to say invalid output instruction position. What does that mean? You've got an output followed by another output, and that does not jibe. Once we put everything on its own branch, we're great. We can have 20 or 30 conditions, one right after another. That's great. The program loves that. Not a problem. But actions have to be on separate branches. Just remember, one action per branch, conditions on the left, actions on the right. And if every condition that's lined up on the left is not true, what happens on the right will be skipped, and it'll proceed to the next rung. The exception, and it's not really an exception, but you can think about it as an exception, is when you have a branch in your conditions. So when we get to this is true, but this is not true. It's not going to jump down to rung 5. It's going to try to take the branch, and it's going to say, what about this branch? Is this true? And if this is true, then it'll go ahead and it'll execute these two outputs. You can think of this ladder like an electrical schematic, where you have a hot wire over here and you have a ground wire over here, and your electricity is going to try to get to the ground. So if there's not a path on this top branch, then it's going to take the bottom branch and it's going to try to get a path to ground. If both of these aren't true and this isn't true, then it's going to give up looking for a path here, and it's going to go down here and see if these are true. And if these aren't true, it's going to go down to here. And if this is true, then it'll execute that and continue its search. That is how a PLC program works. That is a fundamental understanding of ladder logic. And as long as you don't forget that, you're probably going to do all right in the next few lessons. But in the next few, we're going to get into programming. We're going to start discussing different logical operations, various types of conditions, various types of output, and it is going to get a little more complicated. So something I said at the beginning of this section, if you haven't already learned the concepts, input, output, analog, digital, Boolean, float, integer, left to right, top to bottom, program files, rungs, branches, if all of those words don't mean something to you at this point, then I invite you to please go back and review a little bit so that you can get the most out of the following lessons, because we're about to dive headfirst into programming, and if you don't understand these fundamental concepts at this point, watching the next few lessons right now is really kind of going to be a waste of time, and a lot of the concepts are going to be lost. Take the time, go back, do it right, get the most bang for the buck, and when you complete this course, you will be ready to start writing PLC programs.